Hey, welcome back to another episode of P. Willie's Barn. What am I doing today? I'm not going to do it today, but this is going to be a project where I bought this 20-inch Delta Rockwell bandsaw, and it is a 28-350 model. Technically, this is a bandsaw that is made for wood cutting. I was told by the guy that it was for metal. It would do metal, and I didn't know enough about it. It was bought sight unseen. It's in pretty good shape overall. Like, everything spins real nice. Nothing's loose, really. All of these little controls spin like a dream. I kind of sprayed them down just a bit. When he delivered it, it was 4 degrees outside, and I didn't have a way to get it off his trailer easy, so he had brought a little cherry picker. This thing weighs about 700 pounds, is what I looked up online. I was trying to be real strategic and smart. I started taking chunks of wood like that over there, and I would tilt it, because you can tilt it quite far without it going over. And I kept tilt one side, add a piece of wood, tilt the other side, and I just sort of lifted it up as I went back and forth. And then I was trying to get this dolly underneath. It's like a 1,000-pound dolly. And I was standing next to my garage door, kind of probably, thank goodness. I had about 4 feet in between us. And the dolly kicked out, and the machine sort of fell on me. So I just reached up and grabbed it, and I was like, oh, this isn't going to be good. I really don't want to go to the hospital today. Kind of threw me into the door, but I was able to push it back. No problem. And then I got really mad about it, and I jostled the thing in and just twisted it back and forth and finally got it through the door. And, yeah, I never wanted to experience that again, but you do got to be careful with these daggone things. So since then, I went and I was trying to find good ways to mount some wheels to just get it around, because I don't know, my shop's kind of tight. And these Castors are 900 pounds. They're on Amazon, and they're not that expensive, maybe $35, which is amazing. You can't even buy Castors at Harbor Freight for that, but you just step on it, it snaps down, and then you'd still want to be mindful of moving it around, but the thing wheels like no problem. It's awesome. So I'll show you what's going on inside. The guy also told me it was a 110. It was hooked up to 110. It's actually hooked up to 3-phase. 2-belt pulley. That's a 3.5-inch pulley up to a 7-inch pulley. Like I said, everything looks real good. I mean, it's all smooth and works well. Nothing's loose. This is all cast. It's super heavy duty. So now I'm sitting here with a wood cutting machine, which is really well built. I will tell you, I only paid $300 for it. So that's kind of why I was like, you know what, I'm not going to be out regardless. I've seen these go up to, I don't know, there's some crazy prices out there, like $2,600. But I've also seen other ones about $1,600. This, of course, needs to be able to work to get to that point. So, and since then, I purchased a VFD with a dial. It's a cheapie. It was on Amazon as well. Let's see. Okay, there's the model number I got. It was just a Vevor, which I've gotten a few of their things, and that stuff's not actually that bad. Yeah, it's that model, if that helps anyone. And yeah, it's got a dial so I can change the speed. I've read through some of the instructions on it. Oh, by the way, here's the Castors I got. There's the SKU number. You can look those up on Amazon. It's kind of nice because it came with this easy template. I just put holes in it, marked my holes. That was probably the hardest part because there's 24 holes you got to drill through that thick stuff. And I was just laying on the ground. Put a center punch, then a starter bit, centering bit to get it going, and then drilled them out. And then actually this one, there was no access, so I had to have my son help me tip the thing over, block it, and quickly get my hands in there and get all of those 6 nuts and bolts from the bottom. And I did not want the thing falling on me. It was a little nerve-wracking, but all right, so what's my plan here? I think this is going to work well because it's heavy duty for cutting, and it's got an awesome bed, a big table on it. The problem with the 20-inch, I've got a 1750 RPM motor, and that gets reduced down by half, 800 and something. I'll show you that later. I did a whole bunch of calculations. But the 20-inch, the further out you are on the wheel, the faster that wheel is, what would you call it? It's still the same RPM, but it's the velocity of the tip or the circumference of the wheel or of the circle is faster, right? Because it takes twice as this is probably a no-brainer for most of you guys, but if I have to get this whole thing all the way around one turn versus if I was here, right? This is only going like so much blade speed. In the end of the day, that's the same as the blade speed, right? The blade speed is what I'm after. You want to be between 100, you can go lower than that for like titaniums and things, up to like 900. So mild steel, 100 to like 200. Again, I'll show you this later. I got a chart I can share. And aluminum is somewhere between like 600 and 900. And that's so you don't tear up your blade. That's so you got a reasonable feed rate. And you get a nice cutout of it. So with that big wheel, you're talking, I have to reduce this thing by a bunch because it's spitting out like, I want to say like 3,000 feet per minute. And I need to be down to like 100. So the ratio is huge. So how do I fix that? I was trying to understand what other units do that are made for metal. So I did a thing. How am I going to get that ratio down? I'll have to show you the calculation. But what I found is that a lot of these saws, is it heavy or just stuck? It's heavy. They use these worm gears. So I got a 10-to-1 worm gear. And I haven't looked at it yet. Okay, this is what I got. This is a cone drive. It's 10-to-1. It's a 9,000 RPM. It doesn't matter. The ratio is what I was looking for. Somewhere I thought it said the horsepower on it that it would handle. This machine is a 3/4 horsepower motor. Right. So then, let's see, obviously I'm not going to be able to turn this one if that's on the worm. So here's the worm gear side. So this will be the feed side. And if I turn this 10 times, this should spin once, right? So I don't know. But, all right, I will go ahead and share with you. I bought that thing on eBay from this Aero Industry Sales. They had this out to me in just a couple of days. It was only like 95 bucks. I'm going to attempt to share this. Taking video of my computer. So this was the chart that I was using. The SFPM is the surface feet per minute. For aluminum, you can see that it is 492 to 984. Mild steel is 164 to 262. and so on. Titanium is obviously very slow. You're talking that blade speed's like just creeping along. My goal is to probably get it close to like 100 and try to get it up to like 700 or 800 something. Based on that, let's see if I can move this around a little bit. So I just went through, this is just Excel. I always use Excel to throw out this stuff real quick. You can see I got my cost here, even with the gear system, of about 700, which is still cheaper, I think, than what I could buy one for sure. This is the basic setup that is in the saw now. This dark blue lines would be the shafts or something that connects things. So this would be the motor, goes into the smaller pulley, which is a 3.5. Belts hold that together at 7 inches, and the shaft is connecting that to the 20-inch. So this is a 1/2 ratio. So half of 1750 is a 875 RPM. And then if I got some of the stuff off the internet and just trying to figure out how this works, I finally am getting a blade speed of like 4,500. It seems awfully fast, even for wood. So I am going to test that. I have a RPM kind of little handheld gauge thing that I'll stick on there. One thing you got to be definitely aware of is that you got to use the conversion factor for inches into feet, because everything's done on that chart in feet. So what I was looking at first was I was just simply thinking, okay, let's just stick a bigger pulley system on here. They say you shouldn't go any less than 3 inches in diameter for those types of V-belts, or you're not going to get, it's going to be hard on the belt, and maybe you don't get the right amount of pressure in the V area or to create enough friction. So I don't know if you get slippage or not, or if it's just really hard on the belt, but they said 3. So I was like, okay, well, if I go to 3, and it looks like I could maybe fit a 12-inch, which is kind of huge in the box there. And then if I went to see my blade speed, I could only get it down to 755 feet per inch. Or I'm sorry, feet per minute. So my conclusion there was that's not going to work. So then I've seen several videos where they've just put another set of reduction pulleys into the system, but you would have to get some pillow blocks, another shaft, a couple of pulleys, but then you got to arrange those. The motor would have to be shifted slightly to be able to get these things offset of each other, those two sets. So I played around with that quite a bit. I just tried several different iterations of speed of the motor, basically 50% by the VFD on the dial, down to 30%, which I don't know if that motor was going to have enough torque at that point. It might. So I don't know the answer to that. But even with this, I could get it down to 134, which was still like really pushing it, where I'm reducing that VFD and the motor speed so much that I may not want to run very well. Anyways, that did not appear to work so well. So as I mentioned earlier, when I was out in the barn with the machine, how I've seen that. How do they do this? They use the worm gears. So then I played around with a 20-to-1 worm gear. I kind of settled on the 10-to-1 worm gear, where if I'm using the 3.5 and 7, then I could get it down to 458. And if I reduced the speed down, I just put 750 in here, more than half, I can get it down to 196. And I was like, okay, I think I'm comfortable with that. And simply put, this is it written out. Motor speed, diameter A divided by diameter B, then you multiply C divided by D, times the wheel size, put it into feet, from inches into feet by dividing it by 12, multiplied by pi. That gives you your blade speed in feet per minute. And there's the numbers that I installed, and it indeed came out to basically 1145. So there you go. Oh, and this was just more pulleys. The reason I was trying to keep some of the pulleys is the 12-inch pulley is like 50 bucks. That's what I've got going on for how I figured out my gear ratios. Now let me see if I can bore you with this too. Just doing some sketching here and trying to wrap my head around how I'm going to design this. This is basically the current setup. You got the motor. It's on its own base that is secured to this axis. So the weight of the motor pulls down and that puts tension into the belt to give friction. And that turns this wheel, and of course there's another wheel on top. This is that big cast piece that I showed earlier. There is a little bit of space here, which is very important that I need to utilize. And the problem that I've got sort of is the worm gear it comes in on the side, and then it comes in one way and then it comes out the side of the other for the output shaft, which means the motor from the top view inside the machine, pulleys here, motors here, base, and that's that axis that I talked about. So I got to turn the motor 90 degrees and then add the worm gear box so that I can get the pulley in parallel to the current condition. But I think there's space in the cabinet to do it. And my image is to do this finally. I'll have enough space for the pulley, or for the belt, not to rub that housing. I'll be able to shift from here to here, and it'll push that lower pulley into this position. And I'm hoping that I have enough angle here, or not too much angle where I interfere with this. I can always grind that out if I needed to. Prefer not to even dig into any of this if possible. So in order to do this, my image is I still want to use the weight of the motor to put the tension in the belt. It's not straight down, so it's going to be a little, that vector should be down. I don't know. Yeah, you got this difference in angle here. This is where the current position is. I'm going to move this, add another axis, because this axis actually is still used for the foot brake. So I would have to add another axis piece, mount the motor housing to that, extend the motor housing so that I can hold the gear reducer box, the worm gear. All right. So I open this up, and the WVU I was really worried about, because this is what you send to the motor, and you got to get the phases connected correctly. I was very worried about trying to figure out what I had in here, but I see here I got the wires, and it's labeled T1, T2, T3, which I just looked it up. That is the American something electronic way of labeling is the T's. And the WVU is the ICE, International Electrotechnician Commission, or something like that. So I think I can just go T1, T2, T3. I thought about leaving this on here, so if you did have a problem, maybe you could just disconnect it very quickly there. I don't know if I want to use that, though. I'm still trying to decide. It would be kind of neat to keep that, but this has run and stop. I'm going to try to wire this up and at least get this guy going, and then measure the speed and make sure that my calculations are correct before I start monkeying around too much with the whole gearbox. I did decide just to tear all that crap off. I plan on painting the machine back to its original gray color. So all that junk, yeah, the kids can make a robot or something out of it and shove it in grandma's yard. I don't know. But now I'm thinking I want this up as high as possible. And so with the door open, I'm going to mount it as far over to me as possible and as high up, as long as I have enough wires to reach. Yeah, you just run them right through there. And there's really no connections here for anything, so the wires are just dangling. So I'm not really sure how to protect those, but yeah, I'm going to give that some thought. Maybe I'll make something, make a little guard for it out of an aluminum or something or metal and just bend it. All right, clean up the surface a bit for underneath. And the only thing that I'm not caring too much for is that these are some teeny tiny little screws I gotta use because that VFD has just small holes. All right, got it plugged in here. Ready? There's the blade. Tell you what, I'm gonna turn it all the way down to 0. This is on. Let's turn this. There we go. Let's see. That means. Alright, got this guy out. I'm going to crank it because see what happens. Oh, that's a little fast for this. Switch it to RPM and put this tip on here. So let's see what we get. Okay, I'm not sure what the 6.5 means, but I'm going to put this here. 145. I got it turned way down low. I could live with that. That's real slow, right? That's line speed, so I switched it back to meters. Oh, wait a minute. I have to multiply that by 3.8, so that's way too fast still. There, I got it down to 96, so it still has to go half that fast. So it's real slow, but watch this. Try to do it carefully. I can stall this thing so easily. There's 0 torque. So I think I'm heading the right direction. That's good. Because we are spinning, yeah, twice as fast there. That's at 11.6. 200, yeah, multiply that by 3.28. That 600, almost 800. So that would be about the max that I want it. And I'm not putting my hand on that, but I bet that I could stall that out. So we want to be able to use the full motor and spin the other way. All right, that's a good check. All right. I've been playing around with this a little bit, and I've calculated this out. This is at about, well, it was running about 40. I'm going to put too much pressure on it. Let's just say 40. Then you multiply that by 3.28. It gives you about 120 line speed, about. Blade speed is that's how fast that's going. Now let me switch out the tips here and show you what RPM that is. I'm going to switch this to RPMs. It's roughly say 27 RPM. Now watch this. There's no torque, right? Now that's pretty slow. 875 is what I had calculated. Right now, 925, that's faster than I had expected. I'll turn that down to where I think about 875 is-ish. That's about what I thought I'd be spinning at. So there's a huge reduction in speed that I've got to get and keep my torque. That's why that 10 to 1 is going to be perfect. So the VFD definitely can control it down, but you lose all your torque. And we need definitely have some torque on there. So heading in the right direction. This is all hooked up. Yeah, this has been kind of this is a great tool for this. Confirmation. That's the coupling that I got. It's a little greasy, but it looks like that, and it's got a rubber piece in between there. Fits right in. Small side. Fits right on there. That side will go to the motor, and then that'll be nice, because if it's not lined up perfectly, there'll be a little bit of play in here to allow that absorb vibrations and things. So yeah, that's pretty cool. That was just on Amazon. So that's the noise you're hearing. I was going to give you a better idea of what it looks like in the cabinet. So this right here, that is the brake. And it just simply pushes right here. Just what you pull down on the foot pedal outside, turns this over, pulls that down. So I want to leave that shaft, but that's the one the motor is connected to. So my plan is to take another shaft and mount it, maybe somewhere up in here, and then the motor will set in here. This way, gearbox will be pushed over, and it will be good. That's the spring. So earlier I was trying to figure that out. Pushing down. So not only the weight of the motor, but the spring's pushing down. I'm gonna take this out. Looks like I got a collar here. I got a collar over there. I'm gonna pull the shaft out enough to get the motor to drop out. I'll take the motor out through this hole right here, and then we'll start working on it from there. Motor's out. That was a bit of a terrible experience. You got all these collars that don't want to slide. This one I couldn't even get. I couldn't hardly get the brake off, and you can see why. That thing was boogered up pretty good. And in fact, be very careful if you're doing it. Probably a wheel puller of some sort. I ended up breaking. I hit it in the wrong spot. I don't know if I can weld that back together very carefully with a special rod. I don't know if that's cast iron or sometimes you can weld that stuff. But yeah, I had to beat it up pretty good just to even get it to move at all. But I thought that was a better alternative than trying to slide this guy, because this guy won't move either. But now that's on the bench, I'll be able to try to work that out. Anyhow, so that's what I've got. I got my coupler already fit here. Essentially, this is where it's got to go. The pulley's got to go. That pulley's got to go here. This guy's got to go something like this. This won't be here. This shaft will be a different shaft. I'm probably gonna, well, I don't know. And then essentially this guy has got to get mounted here, so I'm gonna have to extend this base. Oh, one thing I figured out too is you have to unbolt this motor to get this out of the housing on this machine. And that was kind of rough after this was already out. I was manhandling it, and you might wear gloves and watch your fingers, because I almost smashed the crap out of mine. This thing's pretty heavy. Okay, so laying this thing out, I mentioned earlier about that gap there. That's about a 3-inch thing. if I touch that to the wall, I'm just about there. If I'm right here, I got clearance. I had measured that gap. If I'm about here, I got room for a little flopping availability there if the belt wants to jump around. And I think I measured that was about 3.5 to 4 inches to about the center. So that's a confirmation there. From here to the other side, inside of the cabinet, it's about 23.5. So I've got my pulleys on. I'm gonna have to knock that off. There wasn't enough room to make that long. Everything's tight. At least the pulleys are. I got my coupler in here. I took a 4x4 piece of metal, marked it out, plasma cutted it, stuck it up on the mill to get my dimension just right. Realized it was too big, which was okay. It was too tall. And I just lined these up next to each other, took the difference and knocked off that little bit on the bottom, and now it's like perfectly lined up. It just slides right in. So I'm happy with that. And I think I'm just going to weld it on. This would be too risky, I think, to just put bolts through here because it's just an open section. And I thought about putting pieces of angle and drilling holes in it so that this could be mounted. And that's still a choice. Am I ever going to turn this into a wood saw again? Probably not. But so then a little bit more figuring out here. I'm getting the motor real close. This is the shaft I'm going to use. I just happen to have this. I'm not worried about that being a little bit close. But then if I go basically about from there to there. Oops, sorry. Let's see if I'm eyeballing that from the top view down. So I'm about 21.5, gives me 1.5 inches on each side. And I'm right at, this camera's not going to do it justice, but I'm right at like 3 inches. So I need to be about here to give myself enough clearance, which puts me real close to the back edge of the cabinet. This is going to be slightly tilted. It was my plan. So I'm going to gain, if I tilted it that much, I would gain quite a bit of space in there. So I will gain a little bit there. But yeah, I guess now I'm trying to figure out if I'm going to weld that or not. Well, the brackets welded, holes are drilled, bolts are on, new holes drilled. I benched tested it as far as fit, and I line up perfectly with that. And good thing that's a rubber thing, so that's gonna allow some misalignment. This has been a real challenge just holding this thing up because it's heavy. But I've got plenty of room over there. And then there's this. The only thing I got to worry about is this wall. So I'm going to be putting that hole somewhere in there. I don't think it's too critical, as long as I got a little bit of angle on it to keep the force, going in the right direction. And I am not putting that extra spring on because I got the mass of that thing holding it down. Very satisfied so far with where it's at. So I got to take some measurements and figure out where that hole is going to go. That's been fairly simple so far, to be honest with you, which is great. This is probably a lot easier than doing the pillow blocks and an extra set of gears. This is working out pretty sweet. These stepper bits are cheap Harbor Freight, but man, they cut just fine. I got my shaft in, it's all mounted. I was able to get my straight edge in there, and I can easily move that back and forth, so I'll be able to get that parallel. Just take it off that surface, that surface, and run it on down. And I line it up there, and I line it up down there, and that will work out really, really nicely. Trying to figure out the best way to mount this, they had like brass couplers here, and I don't have that, and I'm just not going to bother. So my feeling is I was either going to tap this and put a bolt with a big washer on the other side to hold that in there. My other thought is just put a big washer on it, drill a hole, and put a cotter pin through it. I don't think that that is going to have a lot of lateral force against that axis. I hope my wire's long enough. I actually took the motor. I was curious what this cover was for, and all it's doing is just the same shaft coming off the other side, and it already had a key in it with a little spring collar to hold the key on. And I'm thinking that's there kept permanently, maybe for balance, even though I don't think that matters as heavy duty as this is. But I switched directions so that the wiring is closer to where it was previously. So hopefully it'll be long enough. If I didn't, the wire would be on the opposite side in the box, and I would have, 10 inches less wire, and it's already got all these connectors on it. So I don't have to fiddle with that. I would love that to happen. That was not going to look too bad. You walk over here to the other side and you're like, what? And then you look back at your piece and you see that you had a mark on there earlier and you picked the wrong freaking hole. Oh my gosh. Yeah, so what do you do about that? Well, you 45 each side, you MIG weld it, and you're lucky as heck that it just barely fits through your lathe. You clean it off and start over. I feel super lucky that the wire was definitely long enough. I am going to build like a box here, and I think I'm going to put a shut off. But I'll build like a box to cover all this and have a proper mount for the electric. Nobody will ever know. They're never gonna know. All right, motor is tight. It is tightened down. This guy is already tightened down. The belt is, it's definitely got, man, I don't know. Maybe I will have to add that spring on. I didn't want to. I could add weight maybe. It might need it just from jumping around, but I've got my collar set. I had across here to here and then down, so I feel like the pulley is in line. I've got plenty of motor space. Not plenty, but just right. Plenty of room over here. And I got a fantastic angle here. Maybe that'll even allow for a little bouncing without tearing up the belt. And let's see, I've got it plugged in. And you can join me to see if this is actually going to freaking work. You're going to hear my disappointment or my happiness. Let's just set that aside. All right, you ready? Here we go. I'm going to turn it down slow. Okay. Haha, it's spinning. Sounds a little grindy. I guess that's the motor. It's definitely moving pretty slow. That's what we wanted. Okay. You can see the little dot there. That's pretty much as low as it would go. Swing it up. The motor sounds so grindy. And here's the test. Oh yeah, tons of torque. Oh, that's the belt slipping. So I can slow the belt down. But this thing really should run about here. Let's check it out. It probably should be. Pulley. Jackson. cool. Why is my shaft like that? Oh man, did they sell me a bum? I didn't see that before. Well, I'm not digging that. I'm gonna turn her down. Oh, that's disappointing. Well, I mean, maybe if it's spinning slow enough, it won't hurt anything, but something's definitely not good there. Well, the whole motor's moving around. It's all supported off of that shaft. You know, I might run it for a little bit. See if it gets warm. I might have to pull it back out of there. Oh, that's a bummer. At least it's quiet. Can't hear it. And it's also spinning in the wrong direction. Alright, so all we have to do for that is we turn it on to reverse. Maybe it'll sound different. No. So I might be able to, well, it's easy enough just to know which direction it's supposed to go, but at the same time, if nobody hits that, I think I can swap these and get that to go the other direction. I'll have to look that up, but alright, I'm going to do an RPM test. Alright, this is what I've got. So, this is maxed out as fast as it wants to go right now. It could go faster if I change the pulleys, because it's still 1/2. 3.5 to 7, so it's a half. So I could double this speed if I were 1-to-1 or do whatever I want, but if I go ahead and measure that, I'm getting 350, and that would be the blade speed. No, that's but that's in meters per minute. So you multiply that by 3.28, and 150 is equal to 492 feet per minute line speed. So I did that for each of those. Now let's turn it down to like 15. 15's real slow. So 15 is 115. You can see the thing's barely moving, but the good thing is that still is a tremendous amount of torque, which I expected. Of course, that's just me and my fingers here. I'm pushing really hard. I can't stall it, and when I do stall it, I still hear the motor turning, so I think it's just a belt slipping. So that's going to be like pretty slow. I think the other machine I had was up to 160. So if I go up to 20 on the meter, now I'm at 160, and that's what my little Craftsman was running at. And I can turn this on up to 30. I get 233 line speed. A couple of these sound a little better. Like around the 40, it's got some vibrations. If I get up to 50, there, it kind of cools itself down. It doesn't sound so bad. So that 10-to-1 is working for this 20-inch bandsaw for metalworking. All right, and as a, like, the motor is not, it's not even warm at all. The housing here has got a little tiny bit of warmth to it. The coupler is not warm. The pulley's not warm. The shaft behind the pulley isn't warm. So I may have to live with this being bent slightly. And as long as it, yeah, hopefully it doesn't get any worse. I don't think it'll get worse, but it does move this motor around a lot, which is kind of stinky because I don't have any bushings here. But honestly, how long are you going to be running this thing? I just had it on for like 5 minutes. You're going to turn it on, you're going to make a cut, and you're going to be done in, you know, a few minutes. So I don't know. I'm pretty happy with this. I didn't realize how expensive belts were. I got a belt coming in a few days. That was about $60, which I wasn't expecting. Once that on, I'm going to have to adjust all these. I will show you. I have these adjustments here. Well, that one's tight on the other side. So you loosen this guy, and that allows this bearing, and this fine tunes the position of the bearing. And I was missing one of these, and so I made this one on my lathe for the other bit. It seems to be working. And this is a brass material, and oh my gosh, that stuff is, you would think that's soft. First of all, it took forever on my bandsaw to cut, which surprised me. Metal cuts so much easier than this. That doesn't make any sense. The other thing, that there wasn't a lock here. You tighten that and it does the drop bar, so you can adjust the height of this guy, the fence or whatever. I don't know what you call that. So I made one of these up. Still waiting on my blade to get here, but I did put this, cobble this together, aluminum. This thing fits super nice right here. Got it so that it's pretty secure around there. A couple of sheet metal screws, and once I get it all done, I'll fish the wire through this rubber grommet. There's a little space down there. And then I ordered on-off switch, so I don't have to constantly unplug it, and I don't want that VFD running all the time, because even if you stop it, it kind of stays on. And then I'm also putting in a electrical push-button stop, like I showed you I had on that mill. But then watching a few more videos on how to wire this, I think it had the same model number. It's a little older looking machine, or a VFD. And a couple things that I'm glad I saw. The guy was saying that these are set up for European specs. And I hope that I got these right, but the max, or the reference frequency, it's at 50. I changed it to 60 because that's what it is in the US. And the max operating was at 65. So I changed that to 60 as well, because I don't want to go over and burn up the motor, right? Because that's the output. And then it also said that you should prevent the motor from spinning any faster than what it's meant to be, and that motor is the 1750. So I went in to this P21 and I modified that down to the 1750. And finally, the working frequency I set to 60. And those are the ones I watched the video and they recommended, so I'm going to stick with that. And it seems to be running very well. The other thing I found out is with the three-phase, basically, oh, that's just my hand. Basically, you can swap any of these wires one-to-one. I took the W and the U and swapped them. And now it runs in forward, which is good. And with all those changes, I went back through, obviously 65. So when I hit run on this, this is hertz, so I know that now. And I took my maximum, I turned it down to 60, so that no longer exists. And then I just went through and recalibrated. I wouldn't say calibrated, because all I did is measure, but I measured the RPMs again with this guy. And I'm getting well, I'm on 15 right now, I'm getting 35. So I multiplied that by 3.28 like I showed earlier, and That one actually came out just fine. This is my graphical representation based on these numbers. Putting them on there, plotting it. It's basically a straight line. Again, I'm only available up to 60 hertz. So I ran the blade speed versus the hertz on the machine. That way I can just turn that dial and get the right number. I know this video is getting very long, but I just wanted to show a confirmation here. 10-to-1 worm gear, 1750 max speed, which is the 60 that I set it at here, and I was getting a 455 blade speed, 458. That's pretty much right on the money. So they're just spinning full blast. Still got to blow it out from all the wood. I got the belt, or the blade is aligned pretty good. The one thing I'm not sure about exactly is this is the tension, and I got it on like a quarter. You just actually turn this one here, and it's spring loaded. I don't think I really necessarily have to mess with that. And then this is the adjustment for the wheel pitch or angle. And that's how I got the belt aligned. Once that was done, I took loosened these guys up. I'm going to turn this off so I don't accidentally touch it. Cut my finger off here. That's the next thing not to do. I loosened these guys up, and I set this one. Basically, I gave it just a tiny bit of play. I might have to tighten that if I got a better project that I need more accurate. But the blade I got's pretty darn wide, so I won't be able to make too good of curves with this one. But it'll definitely hog out some material quick. Also, I put this guy. Yeah, I might push that forward. Actually, I think it's as far forward as it'll go. A 1/4 inch piece of mild steel, and I've got it running about 28, probably about 175 feet per minute. It does have a little bit of torque issues at this speed. Turn it up just a bit. Actually cutting it pretty fast though. Pretty thick piece of metal. Alright, that's pretty impressive. It's not even warm, barely warm. So no plasma cutter edges, no plasma cutter heat. I'm digging it. It did have a few torque issues there. You saw the blade stop probably, but the motor was still going. So I think that's just a belt. Maybe I need to add more tension to the belt. This might be loud. Oh, that's nice. That's 1/8 inch. I probably won't go that fast normally. Oh my goodness, that's fantastic. It's cutting right through the welds even. Well, clearly that's not going to work. I guess I need to make one. I don't have a 3-inch hole saw, so I thought let's try it in this. So I've got a piece of aluminum. I drilled and tapped it, put a bolt through with a big heavy washer to give it some support, have it marked out, and then I'm just going to go in and cut it this way. The other thing I noticed is that there's a little lip here, so I'm hoping Well, I'll put it in here after I get done. There will be a hole in the middle, and then I'll have to make a slot anyway, so I'm not too worried about that hole. But I'm going to try and incorporate that little bit of a relief there. Right, that was pretty close. Now I got my line there that you can barely see, so I'm going to creep up on it. Yeah, look at that. Actually worked. About a half an hour. It's a little teeny bit proud, so I might put it back on there and take out a little bit of material. I'm not sure to keep it from spinning. It's not super tight. I think I'm going to go ahead and make a couple more while I got my jig set up. And maybe I'll make them just a tiny bit tighter. Alright, well that's basically wrapping it up. I did get my box painted and my switch works. Now I can leave it plugged in and I don't have to worry about the machine being on. I did get an emergency stop, which will be going right there. It's going to look pretty nice, I think. The only problem with it is I only got the 110. So I need one that has the switch on the other side too. So I'm returning this. Those are $10. Like, if you have machines that you're thinking about doing it, just do it. But make sure you get, you can't just kill one pole. You have to kill both poles or the other one's still charged. It's very dangerous. I was trying to figure that out. That is a 220 switch, so all 3 wires are coming in and all 3 wires exit the building on that one. The one thing I do know is you better be wearing these things, man. It is loud. I'm gonna give you one more demonstration because the thing is awesome. Like, that's some pretty thick aluminum, right? And let me kick it on. This guard helps a ton to support the metal, but okay, that's wrapping this episode up of P. Willie's Barn. Like and subscribe. Gotta say that. Hopefully, if you stuck around, you got something out of this. I can't wait to use this on my next project. So, thanks for sticking around. Take care. Until next time.